Hey, what's up, guys? Chung here. So tonight, let's take a look at this week's weekly contest. Problem number 1566. It's hard to believe it's already more than 1500 problems on LeetCode. So this one is called maximum length of subarray with positive product. Okay. Uh, Basically, you're given like an array of integers. It could be positive number, negative number, also a zero. Okay. And you need to find the maximum length of a subarray whose product of all its elements is positive. Okay, yeah. For example, this one, everything here is all the element, the whole array is a positive. The product of the whole array is a positive. For this one, if it's zero, of course it's not positive because everything multiplied with zero will be zero. Okay, so for this one, it's gonna be a one minus 2 and minus 3, or minus 2, uh, yeah, sorry, only this one, 1 minus 2 and minus 3. So yeah, for the third example here, it could be either minus 1 multiplied by minus 2 or minus 2 multiplied by minus 3. Okay, and yeah, and the length of the input is like 10 to the power of 5. So which means this part either has to be a linear or n log n. Mm, so how do we solve this problem, right? So I think the way, at least it's kind of intuitive to me, is by using a DP. Okay. So for DP, since we have, for the current one, right? Because we could have like either the negative or positive number. Okay. Mm, so which means that, at the current position, right? Let's say at the ith position, uh, basically we not only we need to calculate basically the positive length. We also need to maintain the negative length. Because why is that? Because even though at the current position I is negative, but let's say the negative length, let's say is 4, right? The negative length is 4. But if on the I minus 1 position there's another negative number, then this one this negative length of 4 could become a positive 5. Okay. That's why, since we have this kind of like like characteristics of our data, so basically the intuition will be maintaining like two DP arrays. So one is for the like basically we're gonna have like a positive I and the negative I. Okay. So the positive I means that uh ending at I, basically the last element is I, what's the maximum length of a positive uh the the maximum length of a subarray whose product is positive. And for the same for the negative I means uh ending at the last element is I, whose product uh whose product is negative. Okay, so that now with the positive I here, right? So then how about the state transition function? Okay, so this thing is going to become the mm, so basically, we're gonna have like two options for the positive I here, right? Basically, uh, if the number, if the current number, let's say if the ith number is greater than zero, okay? If the current one is greater than zero, so the positive I we can simply get the positive I from the basically the POS. Pos I will be what? Uh, Pos I minus one. plus 1. Okay, that's pretty straightforward, right? Because the current one is positive. So basically, whatever we have, so as long we can just plus 1 on the previously ending positive one, right? The length basically. Mm, yeah. So basically that's that. And how about another function, another like scenario? If the ith number is smaller than 0, so what's gonna be this one? So what's the positive number of this? Mm, okay, so this is a pretty, the first one is easy to understand. So now the tricky part is this one. If the current number is negative, if the current number is negative, what's going to be the positive number here? Positive I equals to what? Equals to the basically mm, going to be something like the negative, right? Negative I minus 1 plus 1. Okay. So seems like we need to use something like this, right? Because let's say if the current one is negative, and we can just inherit the previously negative I minus 1, right? Basically, if the I minus 1 has some is negative, then we can just simply do a plus 1, just like the example we were talking about here, right? But we cannot blindly use this one. Why is that? If the negative I minus 1 is 0, if I minus 1 is 0, which means there's no a negative product before ith number, then the current positive like array should be equal to 0 instead of 1, right? So that's why we have to do a simple check here, right? Basically, uh, if if the negative if the negative I minus 1 is greater than 0, then we can do a positive I equals to negative I minus 1 plus 1. Okay, yeah. So with these two options, okay, so what if the ith number is 0? 0 means that we just need to reset positive and negative to 0. But since we have already initialized the positive I and the negative I, the DP array to 0, we can just simply ignore that the 0 case. Okay, so that's the positive one. But we also need to update the negative one. Okay, so similar as a positive one, it's just like it's gonna be a reverse thing, right? So first, let's say if the current number is greater than 0, what's gonna be the negative I here? Okay. Mm, so if the current number is greater than 0, the negative I we can simply uh yeah, same thing here, right? Because we also need to do a check. Basically, if the negative I minus 1 is greater than 0, then we can check set the negative I equals to negative I minus 1 plus 1. Similar, right? The similar reason because we only increase the negative I in of course in the case of a positive number here when there's like a negative length before, right? Otherwise, if there's no negative product before, like on the I minus 1 position, the current one it should be 0 because the current number it's positive. We only update the negative number, negative I here, unlike only when there's like negative products on the I minus 1 position. Okay. Mm. But when it comes to the negative number here, right? Then we can just blindly update the negative I equals to what? Equals to the positive, basically, right? Positive I minus one plus plus one, right? Because if the current one is negative, right? All we need to care is we just need to care the previously positive because the positive number, previous positive product times the current negative number will also give us a negative number. That's why we do this. Cool. Yeah, basically that's the state transition function. It's a bit tricky and confusing. I agree on that. But yeah, that's the state transition function. And with that, we can just our start coding here basically. And we're gonna have a length of the nums. Okay. And then, like I said, we're gonna have a positive equals to uh, 0. Okay, 0 times n, right? And the negative is also 0 times n. Okay. And since we're doing I minus 1 and a negative I minus 1, we need to initialize the 0 because later on we're gonna start from 1 so that the index will not go out of the boundaries. Yeah, or we can just do a n plus 1 size here, but it's up to you. Okay. And since we start from the 1 here, right, we have to initialize. We need to initialize 0. So it's pretty straightforward, right? Basically, if the nums of 0 is greater than 0, right, then the positive 0 is 1. Okay. And same thing if the nums 0 is smaller than 0. Okay. Then the negative 0 will become 1. Okay. And then we have an answer here, right? The answer will be called, we need to start with the positive 0, right? That's our answer, the initial state. Uh, okay, so I'm hoping I can just save this thing somewhere. Uh, that's fine. Yeah, I believe I can remember this. Basically, if the nums I, right, like what we just said before, is greater than 0, then the first one is the positive I simply because I minus 1 plus 1. Okay, and then uh, else, right? Else the positive, sorry, else if nums I is smaller than 0. Uh, so we do a positive. We need to check if the negative I minus 1 is greater than 0. Okay, if it is, then we just update the positive I equals to the negative I minus 1 plus 1, right? Otherwise, if there's no negative product before, the current positive is simply 0. It's simply 0, right? Because the current number is negative. So which means if there's no previously product result, the positive I will be 0. But since we initialize everything with 0, we can just simply ignore. We just don't update it. So which means the positive I will be 0. Okay, so that's the positive I. Now it's time for the negative I. So basically for the negative I, right, if the negative I minus 1 is greater than 0, right, then the negative I will is like negative I minus 1 plus 1. Okay, and same thing for the negative number case. Basically, if the for the negative case, we can blindly inherit it from the positive I minus 1 plus 1. Okay, and then every time we update that the number the i's positions the i's dp array value, we can simply update this answer dot. Remember, we only care about the positive one, right? And in the end, we simply return the answer. Yeah, run it. Cool. Yeah, I mean, I know this part is a bit tricky. Basically, the key concept here is we need to maintain two DP arrays, since the previously negative length could become a positive length in the current position. That's why we need two DP arrays. Okay, and so for this first solutions, as you guys can see, the time complexity is O of n, and the space complexity is also O of n, right? And you guys have already noticed that since the current I is only relying on the I minus 1, we can compress the space complexity from O of n to what? To O1. Okay, so I'm gonna briefly do it here. So it should be pretty straightforward, right? Basically, we just remove everything here. 0, right? 0, and then here, okay, okay, and then pause, right? So we can just leave everything here, and here we just do uh you know I think the easiest way is gonna be we always do a pause to and positive to and negative to, and in the end we just update that. So otherwise we're gonna have like maybe gonna override the previously one. So basically what I'm going to do, I'm going to have like the pause to represents the new pause. Okay, and this one is the old one. So okay, pause 2 equals to negative 2 equals to 0. Okay. Mm, yeah. So that's that, and so the negative is the old one, and it's negative 2. Okay, equals to negative. And same thing here, right? So if the negative is greater than 0, we have a pause 2 equals to negative, right? And then same thing here, negative 2 uh, pause. Okay, so here just pause 2, right? But remember, in the end, we just update that. Basically, then the positive equals to positive 2 and negative equals to negative 2. Okay, this should just work. Yeah, submit. Cool. See, pretty straightforward, right? Basically, compress the space compression from ON to O1 is pretty straightforward. Basically, we just remove everything. We remove the array. Instead, we're every time we just create a two temporary new new variables as the current one, and for the old one, it's always coming from the previously positive and negative variable here. And we just use the same formula basically as the previously version. It's just in the end, we just assign the new one to this one so that the new one will become the old one for the next iteration here. Okay. Other than that, everything stays the same. Okay, cool guys. I think that's pretty much I want to talk about for this problem. I agree it's a tricky problem, because the reason being is because at the first glance, I mean, you may think about different approaches. Like I even thought about a binary search, or like uh, Or you can, how about a sliding window or something like that? But the tricky part is you have to figure out the correct direction to solve this problem, which, in my opinion, is a dynamic programming. Because at the current position, it depends on the previously positive length and the previously negative length, and depends on the if it depends on the current number, if it's a positive or negative, we need to update those length accordingly, and then we just also maintain the answer along the way. Cool, guys. I think that's pretty much I want to talk about for this problem. Yeah, thank you so much for watching the videos, guys, and stay tuned. See you guys soon. Bye bye.